Hey there guys, welcome to part 2 of the Multiplying Polynomials Day 2 lesson. Now you should have ideally already watched part 1 of the notes, which is the Edpuzzle. As a reminder, Edpuzzles always lock at the day they're assigned. So if it's not locked already, make sure to watch it before watching this part of the notes. But now we can move on to the part 2 of the notes, which is what we covered in the live class. So, really quick, a skills check. So in part 1 of the Edpuzzle, we went over some very important math rules, such as when you're multiplying two different numbers or variables with coefficients, you multiply number by number and variable by variable. So some examples here were, for example, 5 times 2x, well, you'll do number by number, 5 times 2, which is 10. If there's only one variable, such in this case, you'll just leave it as x. So 5 times 2x is 10x. Or in the case of 6x times 3x, where they both have x's, you still do number by number. 6 times 3 is 18, x times x. Really important rule that we learned, x times x is always x squared, no matter what number's in front of it. So number by number 18, variable by variable x squared, 6x times 3x is 18x squared. Finally, a new skill we learned was x squared times x, which is x cubed, or x to the power of 3. This is very important, and we're going to use this a lot throughout this slideshow. So an example is 7x times 3x squared, which is going to give us 21x cubed. 7 times 3 is 21, x times x squared, we said was x cubed. So here are some examples we went over in class. Try to do these, or as many of these as you can. In a few seconds, I'm going to go to the next slide so you can check your answers. So here's the answers. So 2x, or 2 times x, which is going to be 2x. There's only one number, so we keep the number. Only one variable, we keep the variable. 3x times 4 is 12x. 3 times 4 is 12. Only one x, keep the x. X times 3x, well, only one number, keep the number. X times x is x squared. 4x times 5x is 20x. 4 times 5 is 20. X times x is x squared. X squared times 7x, well, there's only one number, keep the number. X squared times x is x cubed. 2x times 3x squared is going to give you 6x cubed, because 3 times 2 is 6. X times x squared, we said, is x cubed. So now actually going into multiplying polynomials, you're going to be able to solve polynomials using a 3x2 box method. So here's some vocabulary review. As a reminder, a polynomial is an expression with two or more algebraic terms, where algebraic terms are separated by multiplication symbols, parentheses, adding, subtracting symbols. So an example of a monomial, which is a one-term expression, is just 3x by itself, 5 by itself, x by itself. A binomial is a two-termed expression, such as 3x plus 1, x minus 4, 5x minus 13. A trinomial is a three-term expression, such as x squared plus 2x plus 1, 3x cubed plus 2x plus 1. Notice there are three individual items within this parentheses. So last class, or in the previous lesson, we learned how to multiply two binomials by each other, which are two-termed expressions by each other, using a 2x2 box method. In this lesson, we're going to be learning how to multiply a binomial, a two-term expression, by a trinomial, which is a three-term expression, using a 3x2 box method. So still the same idea, except it's going to be a little bit more work. So your first step is going to draw a 3x2 box, which is 3 columns, 2 rows. Outside the box, as always, is going to be each term of the polynomial, or each term within each individual parentheses. Inside the box is going to be the product of each number outside of my box. And finally, we're going to combine like terms and simplify. So here's an example. Here's example 2 of your notes template. So given the expression 3x plus 5 multiplied by 2x squared plus 3x minus 6, what you're going to do first is outside the box write each term of the polynomials. So you can see I'm kind of color coding here. I'm going to write my 2x squared, my positive 3x, my negative 6, and on the side I'm going to write my 3x plus 5. So once I've written my terms outside, I can start working on the inside of my box, which is multiplying the product of each term that go outside my box. So in this case, I'm going to multiply 2x squared by 3x. 2 times 3 is 6. X times x squared is x cubed. Then I'm going to multiply these two numbers. 3x times 3x, well, 3 times 3 is 9. X times x is x squared. 3x times negative 6 is negative 18x. 2x squared times 5 is 10x squared. 3x times 5 is 15. Negative 6 times 5 is negative 30. So notice at this point my box is completely filled in, so I can move on to the next step, which is combining like terms. So similar to the last lesson when we combined like terms, our like terms were always in our diagonals. this is still going to follow the same idea, except this time we're going to have two different pairs of like terms we're going to combine. Notice I only have one term with an x cubed. However, I have two terms that have x squared values. So here's an x squared, here's an x squared. So these are like terms. So 10x squared plus 9x squared is going to give me 19x squared. However, notice I also have two numbers that only have an x, such as 15x and negative 18x. These are also like terms. 15 minus 18 is negative 3. So I'm going to combine this to be negative 3x. And then there's only one constant, a number without a variable, so I'm just going to keep it. So my final answer should be 6x cubed plus 19x squared minus 3x minus 30. And this is the product of these two binomial and trinomial multiplication. So example 3, once again from your notes template, same idea. Outside my box, I'm going to write each term for my parentheses. So here's 2x squared plus 5x minus 6. On the side, I'm going to write my 3x plus 4. Inside, I'm going to be multiplying. So 2x squared times 3x is 6x cubed. 5x times 3x is 15x. 5x times positive 4 is 20x. Negative 6 times positive 4 is negative 24. Now I left some boxes empty for you guys, so try to fill it in on your own. In a few seconds, once again, I'm going to show you guys the answer. So this is what you should have filled in. Negative 6 times 3x is going to be negative 18x. 2x squared times 4, well 2 times 4 is 8. Only 1x squared, so you keep the x squared, 8x squared. So now that we have our box filled in, we can begin combining like terms. So identify the pairs of numbers that can be combined. So which numbers can we combine to be like terms? Well, in this case, notice I have two numbers once again that have x squared, the 15x squared and the 8x squared. So those are like terms. 15 plus 8 is 23. So it's a little bit cut off, so hopefully you can still see it here. Similarly, we have two numbers that have just x, 20x and negative 18x. 20 minus 18 is positive 2x. So as always, my like terms are always going to be the numbers diagonal from each other. In this case, we have two numbers diagonal to each other, so we have two separate like terms that can be combined. Moving on to example 4, same thing as we've been doing always. Fill out the outside of your box, where your trinomial will go on top and your binomial will go on the left. Oh, so try this on your own. Try to fill in the box as much as you can. Hopefully at this point you can do these. So h squared times negative 4h. Well, negative 4 will stay since it's our only number. We'll do h squared times h, which will be h cubed. And try to fill this out on your own. I'm going to show you the answer now. So this is what you should have gotten for your box. We would have 9h times negative 4h. 9 times negative 4 is negative 36. h times h is h squared. Negative 4h times negative 1. Negative times negative is positive. Negative 1 times negative 4 is positive 4. Only one variable, 4h. 3 times h squared, only one number, keep the number. Only one variable, keep the variable. So 3h squared. 3 times 9h, 3 times 9 is 27. Only one variable, keep the variable. 3 times negative 1, positive times negative is negative 3. Now we're going to combine our like terms. As always, it's our diagonals. So here are two h squared values. So 3h squared minus 36h squared is going to give us negative 33h squared, which in this case it is cut off. So let me exit out so you can see it. Here it is. They're negative 33h squared. 27 plus 4h is going to give you 31h. Once again, since we only have one cubed function or one cubed expression or term, we're going to keep that negative 4h cubed. We combine these like terms to be negative 33h squared. We combine these like terms to give us positive 31h. And finally, we only have one constant, so we keep it. So moving on to our final example, example 5 from our notes template. This is a word problem. So it tells you to find the area of the shaded region. Well, here you kind of have to be careful. You have to think, okay, how do I find the area of the shaded region? If I just find the area of the large rectangle, well, it's going to encompass everything within here. The shaded region does not include this middle portion, so when I'm trying to figure out the area of the shaded region, I just want everything around kind of this smaller rectangle. So what you have to do is you're going to have to do big minus small. I'm going to have to subtract the area of the bigger rectangle by the area of the smaller rectangle to be left over the shaded region. You can kind of think of we're taking this smaller rectangle out. So I'm going to have to find the area of the bigger rectangle find the area of the smaller rectangle, and subtract. So let's start with the big rectangle. I have x plus h as my length, x plus 6 as my width. Well, I know the area of a rectangle is length times width, so I'm going to multiply these two. Well, this is what we did last time. Now this time, don't be mistaken, this is a binomial by a binomial. 2 terms, 2 terms. So we don't need a 3 by 2 box. We're going back to my 2 by 2 box. So here we'll just fill it in. X times x is x squared, 8 times x is 8x, x times 6 is 6x, 8 times 6 is 48. My diagonals are always my like terms, but I also can tell they're like terms because they both have just x's. So I'll be left with x squared plus 14x plus 48. But that's just my big rectangle. Here's the area of my small rectangle. So length times width. I'm going to do 3x times x plus 3. Now in this case, since it's not a binomial by a binomial, I don't even need the box method. At this point, I can just distribute. So 3x times x is going to give me 3x squared. 3x times 3 is going to give me 9x. Finally, since I found the area of the big rectangle and found the area of the small rectangle, I can now find the area of the shaded region by subtracting. So I'm going to do x squared plus 14x plus 48, that's the big rectangle, minus 3x squared plus 9x. Now as a reminder, back to our first lesson of the unit, adding or subtracting polynomials, it is very, very important to include your parentheses. Now technically I should include parentheses around this as well, but however, since it's going to be a positive 1 in front of my parentheses, it doesn't really matter, but this is where it matters. This subtraction sign, as a reminder, we act as a negative, so I can kind of imagine keeping a negative 1 in front of here. So I'm going to have to distribute my negative 1 when I get rid of the parentheses. So once again, on the left, this always stays the same. X squared plus 14x plus 48. However, on this side, when I distribute this negative, I'm going to flip the sign of everything. So my positive 3x squared is going to become negative 3x squared. My positive 9x is going to become negative 9x. I'll have this. Similar to that lesson, for our first lesson, we're going to combine like terms. Notice I have two x squared values, x minus 3x, which is going to give you negative 2x squared, 14x minus 9x, which is going to give you positive 5x. Since we only have one constant, the constant stays the same. This would be your answer. So this was a lot of work for one problem, but if you knew how to do each individual task, it shouldn't have been that bad. So that is the end of the notes. Don't forget about your homework. Your homework today is going to be multiplying polynomials day 2 homework, so that should say day 2. So once again, if at this point you have not made an account yet, make sure to make an account. The instructions are available on Canvas on the homework page. If you forgot your login information, please send me an email as soon as possible so I can reset it for you. And don't forget about tutoring. So we offer tutoring every day after school, sometimes twice. So for example, on Monday, we offer it twice. On Wednesday, we offer it twice. I lead tutoring Thursdays, but you are free to join any of these tutoring sessions. So hopefully this helped. If you have any questions, feel free to join tutoring or send me an email or remind. Otherwise, have a nice day.